Hello, it's Keith here, and this is lesson 29 of the simple series of my 650 assembly programming tutorials. We're back on the Super Nintendo again, and we're back on sprite clipping, but this time we're not lying, we're actually using sprites. Last time we were using the tile map to simulate sprites, but this time we're using a series of hardware sprites to draw our chibi code character, and we've got a cropping routine which allows the character to go partially off the screen on all sides of the screen, from the top, bottom, left and right. So we're going to do the combination today, and so that's what we're looking at. Now, like last time, we can't set our hardware sprites the same as our tile map, except within VBlank, and so like last time, we're going to be using a buffer to handle that. But just before we look at the actual code that's handling our cropping, let's just quickly remind ourselves of how hardware sprites work on the Super Nintendo. So basically we have a bank of memory here that define each of the sprites. There's 128 in total. Now there's two addresses that define the first part of the sprite data, but each of those addresses takes a word, so 2 bytes. So we've got the X position, bits 0 to 7, the Y position, we've got the X flip, Y flip, the palette and the priority, things like that. We've got the tile number, and then we have an extra 2 bits. Now these are stored at a different address, and there's just a single byte for these, and these contain the bit 8 of the X position, because the X position can go to from 0 to 511, and then they've got the scale bit. So that's the total that we're using. Now the sprites we're using today are 8 by 8 pixels in all cases. We could build our character out of bigger sprites, but I tend to work with the smallest 8 by 8. As I say, this is just an example today. And so we're going to be going over the code today. Now what we're not going to be going over is we're not going to recap over the actual theory. So if you need to know about the theory, please see lesson S28. The first 9 minutes or so will cover the theory of it. So please take a look at that if you need to see that. Okay, well, let's go over to the code and let's take a look. Okay, so here's the code today. We're looking at this SNES bitmap clipping HSprite example today, and we've got our sprite buffer here, and this is going to define the sprite data that will be transferred during our NMI interrupt handler. Now, our NMI interrupt handler will do the job of defining the sprites for us in the VRAM. And the code that's doing the sprites is this part here, and it's all very complicated. But basically this will transfer the buffer into the VRAM, and it does the job of getting the sprites visible on the screen, providing of course you've set up the sprites correctly to start with. You know, you need to make sure you've got your sprites enabled here and things like that. So I'm going to assume you've got the sprites enabled and you've got the interrupt handler enabled. Today we're just going to be looking at the code that actually handles the cropping, the updated code, and also the drawing routine here. So here's the start of the drawing routine. We're loading our X and Y position in 0 page entries B and C. We're loading our first pattern number in IYL here, and we're loading the width and height of our sprite in H and L in logical units. The sprite is 48 by 48 pixels, but our logical units are 2 pixels per logical unit. And then we're doing our do crop routine here, and that will set the carry if the sprite is entirely off the screen. So we will return if the sprite's off the screen. So we're going to be using this to mark our sprite. So if our sprite's entirely off the screen, there's nothing to draw. So that's what that's going to be doing. We'll start this time by having a look at the drawing routine, and we'll go over the cropping second. So the drawing routine here, the X and Y will be now converted to pixels. So we're now loading the X and Y position of our sprite into the X and Y registers here. We're then shifting up by 8 pixels, and we're shifting to the left by 8 pixels. And that's so that our sprite can be almost entirely off the side of the screen. So, you know, when we're doing things like that, maybe the first tile is actually being drawn at a negative position and only 2 pixels are visible on the screen or something like that. That's what this is for. That's to cope with that. And what we're also doing here is, if we are on the negative x-axis, we're setting the top bit, which is actually stored in the L0 page entry. The L0 page entry is the high byte of the X position, and the B0 page entry is the low byte. So that's what we're doing there. Now here is our loop for setting the hardware sprites here. So we are loading our hardware sprite number of the next hardware sprite we want to use, and then we're using this routine set hardware sprite, which is setting one of the hardware sprites. So this routine is setting the buffer as required to get the hardware sprite on the screen. So what we're doing here is we're multiplying the hardware sprite number by 4 to get the first part of the buffer. We're then adding the buffer base here. Now that's defined at the start of our code. That's just here. This is the base at A00 in memory. So we've got the address of the first 4 bytes of our sprite. So we're storing the X position here. We're then incrementing and we're storing the Y position. We're then storing the tile number, and we're storing any additional attributes and the top bits of the tile number there. So that's the first part of our definition. Now, if you remember, I said that the first part uses 4 bytes, but then there's an extra 2 bits here that we also need to set, and these are actually shared among 4 sprites. And so there's a bit of a faff here, and what we're doing here is we're taking the top 6 bits of the sprite number and we're shifting that to the right, and that's to select the correct memory address because there's 4 sprites with 2 bits each per sprite within this area. And then we're getting the 2 bits here and we're using those and we're creating a mask here, and we're shifting the mask and we're shifting the bits that we want to insert here depending on the sprite number. And then what we're doing here is we're effectively getting the current value of the byte, which of course will contain 3 other sprites we don't want to change. We're masking it here, and then we're storing it, and then we're ORing in the new values for the 2 bits of the sprite that we actually want to set here, and then we're storing that back into the buffer here. So that is setting 1 sprite. It's a bit of a pain, but basically you can use this code as is, and you can just set your X and Y position here, and you can set your pattern number, and you can set your hardware sprite number in these 0-page entries here, and this code will transfer hopefully correctly into the hardware sprite, and then of course, as I say, it'll be transferred into VRAM during the VBlank. So that's the set hardware sprite number routine here, and that is setting the hardware sprite. We're then incrementing the hardware sprite number, so we use a different hardware sprite next time, because a hardware sprite can only exist in 1 position on the screen. It can't exist in 2 positions because the first one will disappear by default. That's why in some ways using the tile map is easier for getting started. We're incrementing the pattern number we want to show. We're moving the X position by 8 pixels, and if necessary we are converting the top bit of the X position from a negative back to a positive if the first sprite was partially off screen, but the next sprite isn't. We need to correct that. We're repeating for the width of the sprite in hardware sprites, and then what we're doing here is we're restoring the X position and the width. We're then moving 1 sprite down, adding 8 pixels to our draw position, and then we're skipping any unused sprites, because if our character is partially off the screen, we're going to need to skip some patterns before we start drawing the next line, and that's what we're doing there. We're then restoring the X and Y, and then we are decreasing the Y counter, and we're repeating for the rest of the lines. So that's how we're drawing our sprite to the screen. Now there is one other thing that we need to do when we draw our character to the screen, because we are drawing our player here, but the player won't use the same number of hardware sprites in all cases. You see, when the sprite is on the screen, it will use 36 hardware sprites. So at this point, the character is using 36 hardware sprites. But as it goes partially off the screen, the number of hardware sprites needed will go down. And so if we don't do anything about that, the unused sprites will stay on the screen. And you can see when the chibi code comes back on the screen, they disappear again. So what we're doing to counter that is, after we've drawn our player, we're then just removing any unused sprites from the screen to make sure that that case where the new drawing of the Chibi-Ko character doesn't need as many hardware sprites, we're just clearing them. And so what we're doing here is we are loading the hardware sprite number, and then we're setting the other hardware sprites to 0 here. So that's what we're doing there. Okay, so that's how we're drawing the sprite to the screen and how we're removing it. Let's take a look at the cropping routine. Now the cropping routine hasn't changed so much from last time. However, there are some tweaks, because as I say, we are having to in some case deal with negative drawing positions, and we're also having to alter the sprite to allow for nearly per pixel movement, even if one of the tiles has spontaneously disappeared. So there's some tweaks for that. As I say, near per pixel because we're working in pairs of pixels, because our logical units are in pairs of pixels. So what we're doing here is just like before. We've got this all off screen routine, which is for if the sprite is entirely off the screen, to tell the calling routine to give up. We're then loading Y with 0. Y is 0 throughout this routine, so we sometimes use it as a quick 0. We're zeroing sprite H clip, which is for the case where the sprite is partially off the left hand side or the right hand side, where we need to skip some tiles before we draw the next line. That's what that's for. And DE and temporary variables for our cropping. So we're loading the Y position from C here. We're then subtracting the minimum logical unit position of the screen, and if this goes negative, then we are partially off the top of the screen. We're somewhere like that. So that's what we're checking there. If we've gone negative, we're converting that back to a positive and comparing to the height of the sprite. And if it's the same as the height of the sprite, then the sprite's entirely off screen and we give up. Otherwise, we store the amount we need to crop. And then what we're doing is we're converting the bottom 2 bits to an offset for the Y position. And the reason we're doing this is so that we get a nice smooth movement as the character moves up the screen. If we didn't do this, it would jump quite jerkily. So we're converting the Y position here to compensate as the tiles are being removed, basically. That's what we're doing there. And then what we're doing here is we're storing the new Y position for the sprite, and then we are adding the height of the sprite, and then we're comparing that to the height of the screen in logical units. And if the sprite is off the bottom of the screen, somewhere like maybe that, then we're going to need to remove part from the bottom. We're converting that to a number of sprites because we're having to work in sprites. Even if we are able to move in pixels, we're having to draw in blocks of 8x8 pixels, so that's 4 logical units. So that's what we're doing there, we're converting that. And then we're seeing if we're going to remove the entire height of the sprite, and if not, we're storing the result in D. Now, just like before, we need to skip some patterns if we are going to need to remove some sprites from the top, and also we need to calculate the new height in logical units. So we're taking the amount removed from the top, adding the amount removed from the bottom. If it's not 0, we're negating it, and then we're adding that negative number to the height, and that's going to be the new height. We're converting that to a number of patterns, a number of tiles, because again, we're working in 8x8 pixel hardware sprites, and we're storing that new height here in logical units. Then what we're going to do is we're going to calculate the number of lines we need to remove from the top of the sprite. Now, there is one entire strip of our sprite that is invisible, and to compensate for this, we're adding 4 here, and then we're shifting to the right here, and this is calculating the number of patterns that we need to remove from our sprite if our sprite is partially off the screen. And then what we're doing here is that's the number of lines we need to remove, but then we need to calculate the number of patterns. And so what we're doing here is we're taking the width of the sprite, calculating the width in sprites, and that will be the number of patterns that I use to draw each strip of the sprite of the final graphic. And we're then adding that to IYL, which is the starting pattern count. So we're effectively removing lines of our sprite. If we turn the cat around that, so we're removing lines of the sprite based on each 8 pixel tall strip here. So that's what we're doing there. So we've now cropped the sprite vertically. We now need to do the same horizontally. So we're zeroing D and E again. We're then taking the X position, we're subtracting the minimum X position, and if that's gone negative, our Chibico character must be partially off the left hand side of the screen, somewhere like that. And so we're then going to have to calculate that. Once again, we're having to calculate a shift to cope with the fact that we're going to be removing tiles as the character goes off the screen, but we need to keep the movement in pairs of pixels because our logical units are pairs of pixels. So we're altering our X position as required here. We're then adding the width of our sprite, and we're then checking the width of the screen and seeing if we're going over the right hand side of the screen. If we are going over the right hand side of the screen, then we need to see if the amount we're going over by is the entire width of the screen. If it's not, then we are going to carry on, and we're storing the amount removed from the right in D. We're then adding D and E together, which is the amount removed from both sides. We're then converting this to a number of sprites, and we're storing the amount to remove in sprites into sprite H clip because we need to clip that sprite, whether it's off the left or the right hand side. We're then converting that back to a number of logical units for a moment. We're updating the width in logical units here, and that's going to be needed later, of course. And then what we're doing here is we are taking the amount to remove from the left hand side of the screen, because if the sprite is off the left hand side, we need to skip some of our patterns before we start drawing, and that's what we're doing here. We're adding the amount to remove from the left in tiles, so in patterns, so we're shifting to the right twice to convert it to patterns, adding that to IYL, and then what we're doing here is we're converting our coordinates. Now our X and our Y position are in pixels, so we're shifting those to the left once because one logical unit's 2 pixels, so we're doubling that up, but we need the width and the height in numbers of patterns in hardware sprites. So we're each logical unit's 2 pixels, so there's 4 logical units per sprite. So we're shifting the width and the height to the right twice to divide by 4. We then clear the carry and return, and that's what we need to do to calculate our cropping and draw our hardware sprite to the screen. So there we go. So that's everything for today. As always, you can go to my website, you can download the source code example for today's example, for the previous example with just use the tar map, and also the AccuraSprite editor I used to create the bitmap graphics that I used for today's example. And as I always say, you're welcome to use anything from my tutorials in any way you manage to gain benefit from them. So go ahead and use them in your amazing commercial project if my lousy code can somehow help you in that. So anyway, so do what you can with it. Anyway, I hope you've enjoyed this. If you have, please like and subscribe. Thanks for watching today, and goodbye.